Welcome to video 4 for this unit on linear equations and linear systems. In this video, we're going to focus on systems of equations. Earlier, we studied linear relationships and learned that the values of x and y that make the equation true correspond to the points x, y on the graph. For example, if we have x pounds of flour that cost 80 cents per pound, and y pounds of sugar that cost 50 cents per pound, and the total cost is $9, then we can write an equation like this to represent the relationship between x and y. 0.8x plus 0.5y equals 9. Since 5 pounds of flour cost $4 and 10 pounds of sugar cost $5, we know that x equals 5, y equals 10 is the solution to the equation, and the point 5, 10 is a point on the graph. The line shown is the graph of the equation. Notice that there are 2 points shown that are not on the line. What do they mean in the context? The point 1, 14 means that there is 1 pound of flour and 14 pounds of sugar. The cost for this is 0.8 times 1 plus 0.5 times 14, or $7.80. Since the cost is not $9, this point is not on the graph. Likewise, 9 pounds of flour and 16 pounds of sugar costs 0.8 times 9 plus 0.5 times 16, or $15.20. So the other point is not on the graph either. Suppose we also know that the flour and sugar together weigh 15 pounds. This means that x plus y equals 15. If we draw the graph of this equation on the same coordinate plane, we see it passes through 2 of the 3 labeled points. Since we now have 2 equations, we can ask whether there is an ordered pair that is a solution to both equations simultaneously. The point 1, 14 is on the graph of x plus y equals 15 because 1 plus 14 equals 15. We also know that 5 plus 10 equals 15. But 9 plus 16 does not equal 15, so 9, 16 is not on the graph of x plus y equals 15. In general, if we have 2 lines in the coordinate plane, the coordinates of a point that is on both lines makes both equations true. The coordinates of a point on only one line makes only one equation true. The coordinates of a point on neither line make both equations false. A system of equations is a set of 2 or more equations where the variables represent the same unknown values. For example, suppose that 2 different kinds of bamboo are planted at the same time. Plant A starts at 6 feet tall and grows at a constant rate of 1/4 foot each day. Plant B starts at 3 feet tall and grows at a constant rate of 1/2 foot each day. We can write equations for plant A and plant B, where x represents the number of days after being planted and y represents height. Written as a system of equations, we have y equals 1/4 x plus 6 and y equals 1/2 x plus 3. Solving a system of equations means to find the values of x and y that make both equations true at the same time. One way we have seen to find the solution to a system of equations is to graph both lines and find the intersection point. The intersection point represents the pair of x and y values that make both equations true. Here, The solution to this system of equations is 12, 9, which means that both bamboo plants will be 9 feet tall after 12 days. Systems of equations can have one solution, infinitely many solutions, or no solutions. When the lines intersect once, there is one solution. When the lines are right on top of each other, there are infinitely many solutions. When the lines do not intersect, there is no solution. Lines that do not intersect are parallel. Thank you for watching video 4 of 5 for this unit on linear equations and linear systems.